Right now, take one problem you have been avoiding and write it on a piece of paper. Do not write a goal, write the obstruction, the equation you cannot balance, the paragraph you cannot finish, the sales process that keeps failing. The machine that keeps producing the same defect, put a box around it. That box is now a test chamber. Every time you return to it, you run another cycle through the system. Most people call this obsession. In engineering language, it is duty cycle, the fraction of available time during which a machine is actively operating. Talent may determine the starting torque. Obsession determines how long the motor remains under load. That distinction changes the entire problem of success. Talent is an initial condition. It changes the first measurement. It can give one person faster pattern recognition, a larger working memory buffer, a more accurate ear, a more explosive muscle fiber distribution, or a lower error rate on the first attempt. But initial conditions do not determine the final state of a system when the system contains feedback. Once feedback begins, every output becomes new input. Every attempt changes the operator. Every correction changes the next attempt. The person who returns to the problem 100 times is not the same instrument that made attempt 1. This is the first mechanism. Repetition changes exposure. A person with high talent and low return frequency may touch a problem for 20 hours in a year. A person with moderate talent and sustained fixation may touch it for 500. Even if the talented person extracts twice as much information per hour, the second system still captures far more total signal. Talent changes signal quality. Obsession increases the number of samples, but raw repetition is not enough. A factory can produce the same defective component 10,000 times without improving the tolerance by 1 micrometer. Improvement begins only when the output is measured against a reference, the deviation is identified, and the process is adjusted. This is closed-loop control. Your thermostat does not heat a room because it is motivated. It heats the room because a sensor compares the actual temperature with the target temperature and switches the system in response to error. Skill develops through the same architecture: attempt, measurement, error, correction, new attempt. Anders Ericsson, Ralph Krampe, and Clemens Tesch-Römer described this structure in their 1993 work on expert performance. The useful unit was not generic practice. It was deliberate practice, work designed to improve a specific component of performance, usually with immediate information about failure. The distinction is mechanical. Playing the same song from beginning to end is production. Isolating the 4 measures that collapse at 112 beats per minute, reducing the tempo to 84, changing the fingering, recording the result, and repeating until the timing error falls below a chosen threshold, is calibration. Obsession becomes powerful when it attaches itself to calibration rather than fantasy. A person obsessed with the image of success can spend years consuming symbols of success while producing no measurable change. A person obsessed with the unresolved mechanism behaves differently. The first person watches the scoreboard, the second person opens the machine. One collects emotional voltage, the other traces the circuit. Richard Feynman's published advice on learning did not begin with a claim about natural brilliance. It began with selecting a problem that genuinely held your attention and working on it directly. He argued that a self-chosen problem you wanted to analyze, test, or manipulate was one of the strongest ways to learn. The important word was not easy, it was interesting. Interest kept the circuit energized long enough for difficult operations to become possible. That is the second mechanism. Obsession raises return probability. Every difficult project contains activation energy. In chemistry, a reaction may be energetically favorable and still fail to begin, because the molecules cannot cross the initial barrier. Work behaves the same way. Opening the document, rebuilding the test fixture, loading the dataset, reading the failed calculation, and exposing yourself to another incorrect result all require startup energy. When the problem has become personally magnetic, that barrier falls. You do not need to negotiate with yourself every time. The system restarts with less external force. This does not mean the work becomes pleasant. Deliberate practice is often unpleasant because it holds the operator precisely at the point of instability. A weight that never challenges the muscle produces little adaptation. A problem set containing only operations you already control produces little new structure. Useful practice keeps the error signal alive without making the task so chaotic that feedback becomes meaningless. The correct zone is not comfort. It is controlled failure. Controlled failure is where talent loses part of its advantage. The talented beginner can receive weak error signals because early tasks are easy. The output is praised and the process remains unexamined. The less talented beginner receives error immediately. If that person stays in the loop, assumptions are exposed, weak components are isolated, and the model is rebuilt. The disadvantage becomes a diagnostic system. This is not a law that guarantees victory, it is a mechanism that changes probability. A 2014 meta-analysis by Brooke McNamara, David Hambrick, and Frederick Oswald examined deliberate practice across games, music, sports, education, and professions. Practice explained about 26% of performance differences in games, 21% in music, 18% in sports, 4% in education, and less than 1% in the professions included in their analysis. Those numbers destroy two myths at once. Practice is not everything. Talent, opportunity, instruction, health, resources, and chance remain in the system. But practice is also not decorative. In several domains, it accounts for a large block of variance that cannot be replaced by wishing. The correct conclusion is not that anyone can become anything. The correct conclusion is that you should not depend on the variable you control least. You did not select your nervous system at birth. You did not select your bone geometry, your baseline processing speed, your family resources, or the decade in which you entered the market. Those are boundary conditions. They matter, some are decisive in specific domains. No quantity of obsession will make a 160-centimeter adult an elite professional center in modern basketball. Physics imposes constraints. Intellectual honesty requires saying this. But most people do not fail at the physical boundary of human capacity. They fail far earlier at low cycle count. They stop after the first public error. They change projects before feedback becomes legible. They interpret slow output as fixed inability. They compare their fifth iteration with another person's 500th. The sentence changes from "this method failed" to "I am not talented." That diagnostic error removes the sensor from the control loop. An engineer does not insult a prototype. An engineer reads it. The broken joint, the overheated bearing, the unstable waveform, and the cracked weld are information. They identify the location where the model disagrees with reality. Personal work produces the same evidence. A rejected proposal contains load data. A video with low retention contains a time-dependent signal. A failed exam contains a distribution of missing operations. A business that cannot retain customers contains leakage. Once failure is converted into a measurable defect, it becomes workable. Feynman's career repeatedly returned to this physical attitude toward problems. At Los Alamos during the Manhattan Project, he moved among groups working on calculations and listened as they explained their obstacles. In one account, a team had been stuck for 3 months. During the explanation, he suggested a different route, and the problem was resolved within about half an hour. That moment can be misread as effortless genius. It was not generated in 30 minutes. The visible solution was the discharge of a system that had been charging for years through mathematics, physical intuition, calculation, and constant contact with unresolved problems. A capacitor can release energy quickly, only because it stored energy slowly. This is the third mechanism. Obsession builds compressed representations. A novice sees separate facts. An expert sees a single structure. The novice reads 10 independent terms in an equation and consumes working memory on all 10. The expert recognizes a conservation law, a symmetry, a boundary condition, or a familiar instability, and compresses the same information into one functional unit. This is called chunking in cognitive research, but the engineering analogy is data compression. The expert has not removed information. The expert has encoded it more efficiently. Compression creates apparent speed. When Feynman looked at a physical problem, he could often convert formal symbols into moving parts. Arrows, rotations, paths, forces, amplitudes, and limiting cases. This did not mean he avoided mathematics. It meant the mathematics had been connected to an internal simulator. He could vary a parameter and predict the direction of change before completing the calculation. He could test an equation at zero, at infinity, under symmetry, or under a change of units. Each test was a low-cost probe. People call the result intuition. Intuition is often a library of compressed error. Every failed attempt contributes only if it is retained in a form the system can reuse. 10 years of experience can mean 10 years of adaptation, or it can mean 1 year repeated 10 times. The difference is whether the model changes. Obsession creates the possibility of model change because the same problem remains resident long enough for patterns to accumulate. The mind begins detecting regularities too small to notice in isolated contact. A machinist hears a change in spindle load before the alarm. A programmer notices a race condition from 3 lines of a log. A physicist sees that an answer cannot be correct because its units are wrong. These are high-resolution sensors built through repeated coupling to a domain. The coupling must be continuous enough to preserve state. Sophie Leroy's experiments on task switching described attention residue. When people move from one unfinished task to another, part of the cognitive system remains attached to the first. The next task receives reduced processing capacity. In machine terms, the processor has changed applications without clearing memory. Obsession can reduce this loss when it produces long, uninterrupted runs on one important problem. The system reaches operating temperature and remains there. This is why scattered ambition often produces less than narrow fixation. 10 projects feel like 10 opportunities, but they also create 9 extra interfaces every time you move through them. Each interface carries switching cost, context reconstruction, file loading, emotional recalibration, and loss of working state. The total friction may consume more energy than the work itself. The solution is controlled batching. One problem receives a protected interval long enough for deep state to form. Communication is grouped. Measurement is scheduled. The circuit is opened only at defined points. Obsession without architecture becomes noise. Obsession with architecture becomes throughput. There is a fourth mechanism operating beneath this one. Repeated return changes automaticity. Philippa Lally and colleagues at University College London followed 96 volunteers as they repeated a chosen behavior in a stable context for 12 weeks. The time required for automaticity varied widely rather than converging on a mythical fixed number. The curve rose quickly at first and then flattened. Missing one opportunity did not destroy the process. Repetition in a consistent context gradually reduced the amount of conscious control required to initiate the behavior. That matters because attention is expensive. At the beginning of a skill, every component requires manual control. The writer must think about structure, syntax, evidence, pacing, and tone at the same time. The musician must think about pitch, timing, pressure, posture, and sequence. The engineer must think about units, assumptions, tolerances, materials, and failure modes. The control panel is overloaded. With correct repetition, lower-level operations migrate into automatic routines. Conscious bandwidth is released for higher-order decisions. Obsession accelerates this migration by increasing cycle density. The mechanism resembles compiling code. An interpreted operation is translated line by line each time it runs. A compiled operation is converted into a form. The machine can execute with less overhead. Repeated skill components become compiled. You no longer calculate every letter when typing. You no longer consciously regulate every steering correction on a familiar road. The saved bandwidth can be redirected toward strategy. But automation has a danger. It can compile error. If the repeated movement is wrong, the wrong movement becomes efficient. If the repeated explanation is vague, vagueness becomes fluent. If the repeated business process attracts the wrong customer, scale increases the damage. This is why obsession must remain connected to external measurement. High repetition without correction creates a stable defect. The machine becomes very good at producing the wrong part. Feynman's method was hostile to stable defects. He repeatedly forced abstractions back into contact with physical reality. During the 1986 investigation of the Space Shuttle Challenger disaster, layers of technical language and administrative confidence surrounded the behavior of the solid rocket booster's rubber O-rings at low temperature. Feynman reduced the issue to a material test. He compressed a sample of O-ring material with a clamp, placed it in ice water, released it, and showed that the cold rubber did not recover quickly. The demonstration did not replace the full engineering analysis. It exposed the mechanism in a form the room could not hide from. Reality became the instrument panel. That episode reveals another property of sustained fixation. It creates intolerance for decorative explanation. When you have lived with a problem long enough, verbal fog becomes physically irritating. You want the variable, the tolerance, the pressure, the temperature, the failure rate, the unedited result. You stop accepting labels as mechanisms. You stop confusing the name of a phenomenon with an explanation of the phenomenon. This is the fifth mechanism. Obsession changes the standard of proof. A casual observer is satisfied when a statement sounds coherent. A committed operator needs it to survive contact with the machine. The casual observer asks whether the plan is impressive. The operator asks whether it closes the loop. The casual observer collects advice. The operator builds a test. Feynman warned against believing an answer merely because a model appeared to agree with limited observations. In the Challenger work, uncertainty appeared everywhere. The responsible response was not confidence theater. It was explicit error bounds. This matters for success, because the market, the laboratory, the audience, and the material world do not reward internal certainty. They respond to output. Output is the final measuring device. You can feel disciplined and produce nothing. You can feel untalented and produce a working design. You can feel confident and be wrong. You can feel doubtful and be precise. Internal state is not the reference standard. The result is obsession helps only when it increases contact with the reference standard. Publish the small version, run the load test, send the proposal, record the performance, measure retention. Ask the user to operate the prototype without instructions, put the claim where reality can apply force, then study the deformation. There is also a biological limit that cannot be ignored. A machine operated continuously above its thermal envelope does not become dedicated. It fails. Human learning requires sleep, energy, and recovery. Sustained sleep restriction reduces attention, working memory, mood regulation, and error detection. Obsession that destroys the sensor array eventually reduces the quality of every cycle. The system may remain active while useful output falls. Therefore, obsession is not continuous strain, it is continuous return. The distinction is critical. Continuous strain means the system never unloads. Continuous return means the problem remains stable across days while work and recovery alternate. Muscles adapt between loading sessions. Memory traces are reorganized during offline periods. Solutions often appear after temporary disengagement because the conscious processor stops forcing one route while other associations continue to reorganize. The project remains active at the scale of weeks and years, not at every minute of the day. Feynman used solitude to sift ideas. He also played drums, drew, traveled, and entered subjects outside theoretical physics. These were not proof that fixation was absent. They show that a dominant curiosity can coexist with variation. A rigid machine fractures under vibration. A resilient machine includes damping. The word obsession needs calibration. It does not mean clinical compulsion, loss of control, or destroyed health and relationships. It means a voluntary asymmetry of attention. One class of problems receives more cycles. That bias produces depth. Depth then creates transfer. A person who has studied one mechanism deeply begins recognizing its structure elsewhere. Feedback appears in biology, business, electronics, and behavior. Resonance appears in bridges, voices, markets, and attention. Bottlenecks appear in factories, software, organizations, and thought. The domain becomes a training ground for general models. Feynman's diagrams did this for quantum electrodynamics. They represented interactions in a visual bookkeeping system that allowed difficult calculations to be organized around lines and vertices. The diagrams were not sketches replacing mathematics. They were operational interfaces connecting physical processes to mathematical terms. In 1965, Feynman shared the Nobel Prize in Physics with Julian Schwinger and Shinichiro Tomonaga for fundamental work in quantum electrodynamics. The public sees the prize as a single event. The machinery behind it was years of contact with a technical problem that resisted ordinary representation. Success appears discontinuous from the outside. It is usually continuous inside the system. The paper is accepted on one date. The company crosses profitability on one date. The athlete wins on one date. The theorem closes on one date. The video reaches 10 million people on one date. These events look like voltage spikes, but the circuit was accumulating charge through hundreds of low-visibility cycles. The spike is not the process, it is the measurement becoming public. Depending on talent is structurally weak. Talent is most visible early, when the sample size is small. One person learns faster in the first week, so everyone assigns a permanent label. But long systems amplify return rate, feedback quality, instruction, access, error tolerance, support, and time. Obsession is a multiplier because it acts on several channels at once. It increases hours, lowers, restart friction, preserves problem state, produces more errors to study, builds compressed representations, automates simple operations, and keeps the project alive long enough for chance to enter. Chance needs an active surface on which to land. A useful conversation cannot modify a project you abandoned 2 years ago. A new tool cannot accelerate a system you never built. A market opening cannot help a skill that remained at beginner resolution. Persistence does not command luck, but it increases interception area. A larger antenna captures more signal. The evidence does not support the claim that obsession guarantees success. No honest model can support that. External constraints can dominate. Competition can be stronger. Timing can fail. Illness can interrupt the system. Capital can run out. Another design can be better. The world contains noise, unequal starting conditions, and irreversible events. The stronger claim is narrower. Sustained, measured fixation reduces dependence on talent because it creates additional mechanisms of improvement that talent alone cannot supply. Talent cannot supply your 500th correction if you stop at 20. Talent cannot supply domain-specific memory without exposure. Talent cannot automate an operation you never repeat. Talent cannot reveal a failure mode you refuse to test. Talent cannot build trust with an audience you address once. Talent cannot accumulate a body of work while remaining potential. Potential is stored energy with no circuit. Return to the problem you placed inside the box. Do not ask whether you possess enough talent to solve it. That measurement is unavailable, unstable, and mostly useless. Measure the variables that can be read: hours of direct contact, number of finished attempts, error categories, time between feedback and correction, frequency of uninterrupted work, recovery, output. Then alter one parameter, reduce the interval between attempts, narrow the task, increase feedback resolution, remove one source of switching, build a fixture that makes starting easier. Create a test that can fail clearly, repeat until the error changes shape. When the same error disappears, move the load. When a new error appears, the system has advanced. That is what progress looks like from inside the machine. Not confidence, not identity, changing failure. Feynman was gifted. Denying that would be dishonest. He also kept returning to problems, testing pictures against equations, equations against units, claims against experiments, and authority against physical evidence. His talent mattered. His operating pattern made the talent productive. You do not need to copy his personality. You need to understand the mechanism. Talent changes the first slope of the curve. Obsession extends the curve. And over a long enough run, the system with more honest cycles becomes a different machine.